the journey of NextGames when we started 4 years ago and we decided to build the backend to support our free-to-play games. So it's quite technical talk, but I hope that there will be something for everyone here, or at least you will have some inspiration from the lessons that we've learned, sometimes the hard way. Let's start by the most exciting part of the talk, me. So I'm Sylvain. My background is in software development, a bit more traditional. I started something like 20 years ago, working in distributed systems for financial software with ad hoc server and database. It sounds very boring. It was actually super interesting because back then there was no cloud services, nothing like that. So we had to build everything ourselves. 7 years later, I found a real job, started working in games. That was my passion forever. So the first job was to actually start my own company with a bunch of friends. And of course, back then there was not much available on the market, so we had to build our own game engine, which was some kind of entity component system written in C++ with some scripting language bindings, and using also a lot of open source components. So that might sound familiar to you as an approach to entering game development, because like 10 years ago, there was not really that many alternatives. We released one game on PC, and then, well, the company was not that successful. So for some time, I worked in different small startups, mostly working on handheld platform first, then traditional consoles. So Nintendo was really big back then, and we were working with a mix of ad hoc game engines and also the first iterations of the commercial game engines. We released something like 15 games across all those platforms, including the big consoles at the time, so Xbox, PS3. And those were the days where the first mobile games started to appear with the revolution of the iPhone. So a bit later, I moved to Finland and joined Rovio, well known for the Angry Birds franchise. I worked there for a couple of years as a tech director, so mostly making sure that the code was reusable, mostly making sure that the game teams were going in the same direction. And after a few years, I joined NextGames, where I'm working more in engineering, meaning this time, now that games are really services, there is a need for someone to make sure that the game team and the server team are able to talk to each other. So this is what I'm doing now at NextGames. Right. A bit of a timeline about NextGames. The company was started 4 years ago. We had an initial round of funding, and Lion Gates, which entered the capital of NextGames as well, so that gave us access to a lot of IPs. And this is the strategy of NextGames. Like, we are working with IP holders and partnering with them in order to expand their brand and have a strong connection with their IPs. A good example of that, after the first game, Compass Point West, which was our own IP, is The Walking Dead. So The Walking Dead, if you're not familiar, it's a like hugely successful TV show in US. It's quite successful and popular in Europe as well, but it's mostly in US. So when we started working with the IP owners of The Walking Dead, AMC, we had only this existing game and a bit of a backend system. So it was for us, the challenge for us was to expand on that and make sure that whatever we would build would sustain the new game, which would be like way more important and more with more players, and also be ready for the future. 6 months ago, we did an IPO. So the story of NextGames is kind of interesting because we started like from zero to IPO in 4 years, which was super fast. Few key numbers about The Walking Dead. So the game, which is out now, we have 450,000 unique players every day, huge amount of data and database requests. So those are the challenges that we have to face every day in order to make the player experience as good as possible. Let's have a look at the high-level services that we are using. There's a lot of details there. I will not go through them like one by one, but just in general, Our technical infrastructure is based on Microsoft Azure. So we are using pretty much all the services that they are providing. And I'm talking about cloud services, which is their abstraction for scalable service. We are also using networking layers, the traffic manager, which is, again, a high-level load balancing system. So the front servers, which host the core of the game logic, are based on these cloud services. We have also external or peripheral services, analytics being one. We decided to build our own solution for analytics, and we are using the cloud services for that as well. The content system is a combination of CDN and Microsoft Azure Media Server that allow us to stream videos directly to the client. And we also, in addition to that, have global services like Leaderboard, which is kind of an interesting challenge because there we have to go through the whole database of all the players. And when you have like this amount of players every day, the database is huge, so you can't do that in real time. And we have a dedicated service for that. Let's talk a bit about the data now. We initially thought that, well, having a traditional approach will probably not scale that much. So as we are using multiple services in Azure, we are doing pretty much the same thing for the data. We try to identify the data access patterns, and we use the tools that are provided by Azure that would give the best performance and that would scale with minimum effort. So for that, we are using the blob storage, which is a simple abstraction for like kind of file-based access. We are also using Cosmos DB, which is their NoSQL database, so document-based, and a more traditional table storage, which is the equivalent of, let's say, SQL database or historical database. And across the different services, we make use of those different data providers or storage provider to get the best performance and the best scalability. Let's dig a bit into more detail and see what were the challenges we were facing or what were the goals we wanted to achieve when designing the platform. Well, first of all, since it's a significant investment in terms of engineering, we wanted to make sure that our platform would support many games. And by many games, I also mean many genres of games. So we designed the platform so that it knows as little as possible about the genre of the game. Of course, they will be mobile because this is where what we are doing, but no specific genre. Another thing that we wanted to achieve is to make sure that every time we add a new feature to the platform, it's available quickly to the game developers, meaning that you can benefit from having a new feature on the platform. You can benefit immediately in all the games that are using the platform. Time to market was critical for us as well. We didn't have that big of a track record, and our second product, No Man's Land, was really key to building more games and proving that the platform was efficient. So we had to release it quickly. And finally, one of our goals was also to make sure that the platform can be operated. So for that, we developed a dashboard that would be the framework for building tools for different departments that will have to operate the game after it's out. To achieve these goals, we identified 4 pillars, and I will go through them and try to share what we've learned following those design pillars. So first one, we make games. We are not a software company. We are really focusing on making games. So we are not building everything. And one of the first things that you need to think about when making a game is what engine are you using? So you could develop your own. That's what we were doing like 10 or 15 years ago. Nowadays, there are many commercial engines that are very suitable for building games fast, that are performant, and most importantly, which are future-proof. So Unity is a good example of that. There was no question, basically, when we started that we would use Unity. The community is huge. It's you can hire like super talented people who have a lot of experience with Unity. You have great support from Unity. So it was a no-brainer for us. And in addition to that, the fact that the scripting language is C# or the programming language is C# already show that there can be a bridge between what Unity is running and what the servers are running, because Microsoft Azure can run C# natively. So going that route on the game engine, we also identified few external services that we would need. And instead of building them, we integrated those services. So logging is a good example of that. When you have a massive platform, you need to be able to troubleshoot and debug and analyze things very, very efficiently. Log entries was a good solution for us. It's a third-party service that allows you to query your logs from all the platforms. I'm talking backend here, so all the services in the backend can be queried. Datadog for a bit lower level monitoring of the machines and health of the system. Also, when we started to have live services, we had to find a way to monitor and react very quickly. So PagerDuty is an external service that allows you to trigger alerts and give information to the players so that they know that the platform is not optimal, for example. And HelpShift is a key tool for us for interacting with the player. So it's more targeted at player support, but it integrates nicely within the game and gives a channel for reaching technical support or game support, actually. So the Game Master key tool is HelpShift for us. But still, we had a lot of extra services to build and a lot of technology to build. Integrating was one, but then how do you build a scalable and secure backend? That was one of the questions, and we had to build that. How to buy the global services? I briefly talked about that, and we'll go into a bit more detail about the chat or social features. How to handle analytics with this amount of data? It's a huge challenge to build an analytics platform, and we didn't do that initially. We moved towards our own solution later on, but it was identified as a key component to measure and understand how the player would behave in the game and help us balance and measure. And finally, the live tools, which is a key element of keeping the player engaged and having a community, vibrant community that is alive and is consuming the content that you provide. So what did we learn while building these things? Well, we make games, but still we have to pick the right tools. And doing that is not that easy. First, you make wrong decisions. You need to adapt. The requirements are changing, so you need to make sure that whatever tool you are picking, it does not tie you infinitely in one area or one direction. So a good example of that is the analytics system, that we made one decision first, and then we realized that that would not scale with other games, or we didn't get enough information back from them, so we decided to build our own. But if you are not ready to adapt to those changes, then you are stuck there and your platform cannot evolve. The second lesson that we've learned is that we need to pick our battles. Well, that's one of the reasons why we decided to go with external services rather than building everything ourselves. If you want to go fast, and time to market was critical for us, you have to make sure that you focus on what brings the most value. And for us, the most value is the value that is perceived by the end user, so by the player. If we have 2 or 3 different technical solutions to handle the connection with the servers, we will probably choose the one that gives the smoothest experience, so the lowest latency, the lowest loading time. And that was also key to focus our effort in what the player would perceive. And finally, also one of the lessons we've learned a bit the hard way, that we initially built our tech around 2 entities. One would be the technology or the server, and the other one would be the game team. And it worked quite nicely. When we were 4 backend developers, it was okay. Like, we were closely integrated with the game team, and it worked. But as the company was growing, we found that it was more and more difficult, and it added more and more overhead to have those 2 entities separated. So what we've been doing since then is that we are making sure that server programmers and game programmers are actually working together. And our server team today is totally distributed in our game teams. All right, second design pillar, never trust the client. Why is that important? Well, the first thing that comes to mind is that you want to prevent cheating. So if you trust the client, then of course the game will report that, hey, I've won this battle and I've won like 400 gold. That will not work. Like very quickly, hackers will find ways and will develop tools that will like unlock everything in your game. So it's key that the client is not trusted so that it doesn't ruin your economy. The way we approach that is we have what we call a deterministic model. What is it in reality? It's the whole game logic. So the game logic is deterministic in the sense that if you do one action on the client, then the same action will produce the same result on the server. And that's the key concept to prevent cheating. Let me show you a little more details about this specific case. So this is how we execute commands. First, the client connects to our servers. Well, there is a bit of round trip to find the right instance and for load balancing and things like that. But in the end, what happens is that we connect to one front instance that will run the game logic for this specific player. So we load the data. We're using JSON for that. And the data is first loaded on the server. Then the data is sent to the client. And that means that the game logic is similar on both client and server. It's the same code. And the initial state is the same as well, because the server is giving the state back to the client. After that, when we want to act, so for example, a player is collecting a building, if there are resources, then we send a command. So we first execute the command on the client. That helps with the validation. We serialize that command, send that to the server. And then the server is executing the exact same command. So because the model is deterministic, then what happened on the client and what happened on the server results in the same end state. We validate that and give acknowledgement back to the client, and we can iterate and move on with the next command. So that's the fundamental like execution flow of changing the state of the player, both on client and server. When the player logs out, of course, we re-serialize the last state and put that back to the storage. Well, this seems like a lot of trouble, so why did we do that? Well, first of all, doing that allows us to write the code, the logic code only once. We don't need to have special validation on the server, meaning that the server team doesn't have to know anything about the game and they can focus on the infrastructure. And that was very important for us because we started with a very small team. So being able to effectively reuse the code, the logic code on client and server was key to having a working platform. The second benefit of that is that you can queue the execution on the server, meaning that you don't have to wait for the server to acknowledge your command before you send the next one. And that's very beneficial to the player's experience. So you can go as fast as you want on the client and then batch all your commands and send them so they can be executed on the server. Of course, it doesn't allow cheating. If we detect something wrong on the server, then we will disconnect the client and say, hey, something went wrong. But the main benefit of that is that you don't have to wait for the server. And finally, one of the additional benefits is that we have the ability to fix problems only on the server. Say, for example, we have a data problem. A good example in No Man's Land is that at some point we introduced an item that was, say, very badly balanced. So we had to remove the item. The problem is that we found a lot of corner cases where players were having the item and were in the middle of a combat, or they were starting to trade the item and things like that. So in order to fix this problem, we could have made a new client version, but that takes time. It needs to go through Apple validation on iOS. And then the client has to upgrade. And Meanwhile, they cannot play the game because the item is broken. So what we did is that we made a small modification in the code only on the server that would allow the game to work and fix this specific item only. So it's transparent for the player. We had no downtime because we can run different versions of the same game with this fix. And that also helped us understanding and diagnosing what was happening. What did we learn on the deterministic model? Well, it's a great idea, but then in the implementation or in the detail, it's not that easy. On the client with Unity, we are running with Mono, and on the server, we are running with the Microsoft CLR. And unfortunately, they don't do exactly the same thing, exactly the same way. So we had to add measure to make sure that the end result on both sides would be identical. Some examples of that, floating point operations, like you can't do that at all, so we had to go the fixed point way. Other examples, like basic things like sorting, can actually be different on client and server. And finding those bugs when you are assuming that having the deterministic model is enough took a lot of time. In addition to that, there is no magic there, meaning that you can still make logic mistakes. Example that happened in No Man's Land is players found a way to disconnect the game, check what the gacha results will be, and if they were not happy, then they will just reset the game, and that would result in a new gacha draw. So they were abusing the way we designed the system, even if it cannot be cheated because we are running the same code, but they found a way to work around that limitation and basically doing as many gacha draws as they wanted before they get the exact result that they want. How did we solve that? Well, it was, again, more on the design side rather than the idea of having a deterministic model. So how did we solve that? Well, now we are having like multiple random generators, and we are using them for one purpose only. So the end result being that if you want to do another gacha draw, you will have exactly the same result, whether it has been used or not. And finally, final point is everybody needs to care about the data. That's also something we've learned the hard way, that more developers add more data to the model, which becomes huge and monolithic, and that results in huge performance impact on the server. So something that might look like very innocent from the client programmer's perspective actually can have a huge impact on the server. So keeping the data small and granular was also something that we are now doing systematically on new games. Let's talk a bit more about scaling. Our first game, Compass Point West, was a success, but with No Man's Land and the brand, we were expecting like orders of magnitude more players and more activity. So scaling was super important for us. Let's see how we address the scalability problem first for connectivity. So basing our solution on top of Azure helped us picking those different tools that gives hierarchical scalability. The first point of contact, so if we go from the left, the user connects to the traffic manager. That's the first point of contact. And we actually have doubled the traffic manager for fault tolerance reason. But the role of the traffic manager is to elect one of the cloud service in a pool of n cloud services. So that gives another level of scalability. And then within the cloud service, one of the instance of the server will be elected. That results in 2 layers of scalability where we can add more cloud services and we can also add more instances per cloud service. So that gives us quite good control over how we want to scale and how much we want to scale. Another problem with scalability that I briefly touched before about the data is that actually our front servers, which is the first point of contact from the client, they are doing caching a lot. That means a lot of memory, and that means that everything that needs to be known by the client has to be known by the server as well. So because our data model was not that optimal for no man's land, we ended up having huge amount of data loaded on the server. And every time client programmers would add some more data, then it would have a huge impact, meaning more cloud services and more scalability problems. One of the other issue as well was that we were keeping the players in memory for too long. That was fixed later on, but it was big trouble for us to know whether we should keep the player or just drop it. Caching in terms of memory is very intensive, but another reason why we were using a lot of resources was also because of the data format that we chose to use. And everything in no man's land is based on JSON. So we found out that actually 70% of our CPU time was spent serializing and deserializing JSON. I'm not saying that JSON is bad per se, or at least that's not what we are saying or what we found out. The thing that we understood is that having only one solution for everything is not right. So JSON might be extremely adequate for some part of the game or some of the data model, but it's not a universal solution. Just to give you an idea, like the 4 megabytes per player, just to store, to do the serialization and deserialization, like if you have 500,000 players per day, that's like a huge amount of resources only to hold the state of the player in memory. So there are better ways, and we have fixed that now. But now, how do we scale the data tier? Like everything has to be stored at some point, right? So the way we store the players is heavily relying on partitions, and we are doing that at several levels as well. So blob storage is the key Azure component that we're using for storing the state of the player. We store that as JSON, but it doesn't have to. The thing with the blob storage is that there is a limitation per storage account. So if you have one storage account, you are hitting a limitation on the number of queries or requests you can do against that storage account. So how did we solve that? Well, we multiplied the number of storage accounts. So we have this level of scalability, like instead of having one storage account, so that's one level of partitioning, we have 96, I think, when we started the Walking Dead. So almost 100 storage accounts, and we do partitioning there. Under the hood, each storage account itself has a way to handle partitioning too. So it gives us 2 levels of hierarchy for partitioning our data. Another key element for scalability was the social aspects of the game. So what we understood is that for player, it's actually quite easy to partition the data and put that only in one location, because it will be loaded only when this player is online. But if you're talking about guild, or say guild chat, for example, then you might have to load the guild chat into multiple instances so that player can talk to each other. How did we do that? Well, this is the basic infrastructure we are using for social features. So if we start from the top left, the client is connecting to the front server. At this point, the front server is subscribing to or registering to our social server. And after that, this front service will get all the messages that are for this social group. So example of guild chat, I have 4 clients there. They are each connected to different fronts, as we've seen before. But they are all registered to the same instance of the same social service. So messages can flow between them. And the only responsibility of the social service is to make sure that the messages are dispatched to all the fronts that have subscribed. On the storage side, it's a bit more tricky, because as we might know when the player is online or offline, in the case of social, well, as long as one player is there playing, then the guild has to be kept in memory. So we clearly identified that we had to have different scalability there compared to what we have for the player. Testing. That's one of the areas where scalability was also a problem. Well, we had this dream of having 1 million concurrent players, but how do you actually test that? Well, we had ideas. Azure provides this Visual Studio Online tools for testing and load testing. We also had this idea of, since we are using this command ID and this model, we could record all those commands and use them as scenario to run load tests, and that's exactly what we've been doing. So we record a session of gameplay, and we can then replay that sequence of gameplay for 1 million players. Well, 1 million players actually didn't work that well. The first time we ran this kind of scenario, it crashed Visual Studio Online. So we went a bit too far, but that's one of the lessons we've learned. Like, if you want to know the limit, then you have to try to break them. And that was like super important for us to understand, like, how far can we push, and can we find workarounds so that we can do this load test to a smaller scale that would actually be meaningful for the bigger end game. Actually, one of the reasons why the Visual Studio Online was crashing was because of a bug in Azure storage system. But thanks to like very good support from Microsoft, we identified and fixed that with their engineers, and the performance came back, and then we were able to test that fully. So it's also important to have very good connection with your service provider, so you can like quickly react to those kind of scenarios and failures that might be caused by your game, but might also be caused by the infrastructure. Estimating the load was also very difficult. Well, we had this idea of what the boundary would be, and we would try as much as possible to stay within those boundaries. But what actually happened when the game was out is that we saw like huge fluctuation in the number of players. So simultaneous connections or peak number of players were varying greatly. And when the game was out, it was in the middle of the TV show. And I remember clearly seeing from the real-time analytics that we had that there were spikes of users in the game that were matching exactly with the commercial break during the TV show. So you have to adapt very quickly if you want to absorb this kind of load, and we were not really prepared for that. Well, fortunately, we had huge scalability and great support, so we were able to absorb that, but we couldn't have guessed beforehand. Scaling services differently is also important. The example there is between the player services and the social services. We have different requirements. The data has to stay hot a bit longer for the social services, and also the requirements in terms of networking are a bit more heavy. So it's good that those services are clearly distinct, so they can be scaled up and down more optimally. Let's talk about the fourth one. Going live is the beginning. That was, of course, part of the initial vision when we built the backend, but I'm coming from an old school programmer, making games on console. You put that in a box and put that on a shelf, and then it's done. That doesn't really work that well nowadays, especially with free-to-play games. So they have to be services, meaning that when the game is out, it's the beginning of the story. This is where the interesting part happens, but it's only the beginning, meaning you have to be ready to grow your content. So delivering new content is key. You have to evolve new features as well, and that with as little disruption as possible. And finally, you have to build and maintain your community. One of the key metrics is player retention. So we want to make sure that the players are engaged and are still using the new content. So having a direct connection with the community is also very important. How did we do that for the content itself? Well, let's go through two examples. One is the live video that we are streaming. So usually what we are doing is, what we can do is that we can tease for features that will appear in the next version, or give a teaser of the new episode of the TV show through the game. And for that, we are using the Azure Media Services. Everything is controlled through our dashboard. So this is our live operation tool. And we can decide that, hey, let's now start advertising the new episode. We push that through a controller. It reaches all the game instances. And then when the player is connecting to the game, he gets this new content delivered. Another example is when we have announcements, news, for example, or promotions, or events starting. Same thing. We start from the dashboard, which is our content controlling system. We push that to all the game instances, and when the player comes, they get the new contents available. This can be distributed directly from the game service, but also it can be accessed through CDN. And that's extremely important to have this dashboard as the controlling way to deliver the content, because you don't want to push content that would hint towards something that will appear later in the show, for example. And that has happened to us as well, that we had one of the characters there that was not announced yet or not public there. So people will find out always. It's also important to have the dashboard in order to be able to deliver specific content for specific players. And we built our tool set on top of this idea so that we can do A/B tests. We can identify segments and deliver specific content to specific players. So these were not there on day one, but of course we had to build them. What did we learn? Live operation, you need to think about that from day one. It doesn't mean that you have to build all the tools, because actually we learned also that you don't know what you need. You learn what you need as the game is progressing and as the game is evolving, which is a constant feedback with the community, the IP owner, and also the game design. So you need to adapt to that and build the tools as they are needed. But it's super important to dedicate enough resources from day one so that you are able to build those tools. Just 4 examples. The notification system, to be able to connect with the players or to re-engage them. This is mostly a marketing tool, but it's extremely useful to keep the community there. Campaign management is along the same lines. We want to communicate differently to players who are high spenders and maybe players who are not playing that many sessions per day, which is related to segmentation. So segmentation and campaign management go hand in hand. We need to have a way to go through all the players and make sure that they get delivered the content that is the most appropriate to them. And finally, attribution, which is something that is more in the user acquisition side, which is key for them to optimize the strategy we have for acquiring new users. So we want to know what channels the users are from and how well they are playing the game and how well they are monetizing. And those tools, they need to be embedded in the platform and visible through our live operation. So that's the end of the 4 pillars. So with all those lessons learned, like what are we doing now? Well, we announced like a few months ago that we are working on the new The Walking Dead game, which will be location-based with augmented reality. And with what we've learned from No Man's Land, we improved on that. So the monolithic services that we had are now broken down in smaller chunks. So we are going the microservices way, and that will help us with scaling with even more granularity. So for that, we're using Service Fabric, which is the new Microsoft infrastructure for doing microservices. Closing the feedback loop is also, now that we have our own analytics platform, what we want to be able to do, instead of running the traditional A/B test, is to tweak the game constantly based on how the players are playing the game. And we already have the first signs of this happening, but we need to put a little bit more effort so that there is less manual control, but the game will optimize itself. And finally, better abstraction for the games themselves, and I'm talking about development teams there. So this is one thing that we are now doing. We are building an SDK on top of the platform. So the first 2 games, they were like very rudimentary interface with the servers. But as we built the platform, we understood that the level of abstraction is very important so that we avoid the same mistakes of players finding workaround to cheat the system, or that we hit one of the bottlenecks for scalability. And we have put a lot of effort recently into building those SDKs, and it shows already successes that we have like 3 games in development at the moment, and the teams are showing a lot of creativity in how they are using the systems without involving too many engineering resources on the backend side. All right, that's it. Thank you very much for having me. If you have questions, I think we have time.
Для вопросов у нас здесь есть стоечка.
Привет.
Is the microphone working?
Hi.
Okay. Well, thank you for the game, first of all. I play it every day, actually.
Thank you.
I have multiple questions. I don't know if anyone is going to ask any, so I'm going to just... Okay. The first one is technical one. Can you tell more about analytics solution or the first iteration and what's your custom solution is, and especially about attribution? Do you use third-party services or you build yourself it? Yeah.
Let's start with this one.
Yeah.
So, yes, for attribution, we are using third-party services. One of the reasons, or one of the key reasons for that is developing your own solution requires a lot of effort to match the user with the advertising channel. So I think it's something that we decided that we would focus on making the games and the technical platform, and user attribution is something that is handled like relatively well by third parties. So we are still we are working with them. Actually, we are also using these third parties for as little as possible, meaning, well, one of the problems here is that when you integrate a new service or a third party, especially attribution, which has to have an SDK on the client side, then you are putting a lot more on the client, meaning that you need to upgrade and maintain that, and that's a problem. So the more SDK you had on the client, the more difficult it is to maintain. So we try to limit that and do as much as we can with server-to-server communication. But attribution is third-party. Now, when it comes to analytics in general, gathering the data, because the client and server are running the same code, it's kind of nice to be able to report the analytics on the server side. So we don't have anything on the client to report analytics. If we want to report client-side analytics, like memory, CPU, these kind of things, we are doing that too. But it's orthogonal to gathering data about how the game is played, which is key for balancing the game. And for that, we have developed our own service. We are exporting all those events. We are streaming them actually in real time. We put them in this Azure event hub thing. And this, which is a message queue basically, and this message queue is consumed by consumed and injected into Google BigQuery. So we are using Google BigQuery for actually exploiting the data.
Thank you. The next question is related to game design, mostly, if you could answer that as well. Do you look up to other games based on Walking Dead franchise? For example, Walking Dead Road to Survival is also a mobile free-to-play game with the base and the fighting mode. Do you treat them like your competitor or like a source of good ideas? Do you have any ideas that you, I don't know, take from them and adapt it in the game, or you plan to? Because they, for example, they have a deeper PvP mechanics, while No Man's Land is more like a asynchronous and single-player game.
Yes. Yes, of course we are using their ideas, but not more or not less than any other games. Like, we are playing a lot of games. We are really focused on that. So good ideas are a source of inspiration, whether they are coming from Road to Survival or another game. That's totally fine. Also, I don't think that we are really competing against us, because they have they are close to the comic books, and we are on the TV show. So what we can do with the TV show is actually pretty different than from the comics, and that's why the game is going also in a slightly different direction. But a good example of that is when they started the Talking Dead, so the talk show after the episode. We also had an opportunity to work with the host of the Talking Dead, and we asked the community to design a character. And that's something that is way more like interactive than purely sticking to one brand. So there are differences, but they are not that
Well,
much of a competitor.
anyway, I treat it like this franchise as the whole universe. Anyway, even if it's a TV show or comic books, I think that for people it's no matter what these media source is. And one more is a business question. Do you think? Well, the mobile market of mobile games is very competitive, and it's hard to start start at this moment when the market developed and you don't have a huge franchise. Is there life for other mobile developers for small teams like 20 devs? Is it possible, or how much success of is dedicated to the title?
Well,
I mean,
is there a life for small teams of 20 developers? Yes, absolutely, definitely, for sure. Like, I wouldn't be here. 5 years ago, when I joined the company, there was actually 20 people, and we just had the franchise. But before that, the company had still worked for a year on Compass Point West, which was based on our own IP. So yes, there is room, and the track that we have followed went straight to the IP owners because that was our strategy, and there are multiple other ways to be successful on the market. So yes, absolutely, yeah, there is life.
Okay, thank you.
Hi.
Hi.
Thank you for your speech. I want to say that we had almost the same architecture in our project and faced almost all those issues. So I noticed that you are using C# as a language for the server and the client logic, shared logic. And you are using Unity. So did I understand it right that you can't reload client logic? For example, you said you mentioned hot fixing, and you mentioned that you fixed something only on a server side. Am I right?
Yes.
Okay. And the second question: how many times did it really beat you when you need something hot fix and you can't hot fix it on the client side?
Too many times for me to remember, like a lot of times. So having this capability, having this option of fixing stuff without releasing a new version of the client is, at least for us, was like very, very beneficial. One of the problems is that if you have to go through the whole cycle of certification or validation by Apple, then players will not be able to play the game or will have a degraded experience. So of course you can find workarounds, like using feature flags or data-driven as much as possible. But in the end, if there is a bug in the logic itself, you have to fix it. And it's not always the case that you can fix it on the server, but being able to do that is already like removing some of the downtime or maintenance mode.
So in the end, it was worth it to make C# shared logic.
Yeah, absolutely. Yes.
Okay, thank you.